All right, welcome chemistry students. We're going to go through one of the trickiest versions of the ionic compounds that we've been working with. All right, what we see, it's a binary compound. Cu is copper, so it's a metal, non-metal, it's an ionic compound. And Cu is in that middle section of the periodic table, it's a transition metal. So when we go to name it, we know it's going to be copper and it's going to be chloride. All right, we're going to get that ID ending. But we don't know what type of copper it is, and we have to tell it. All right, so I'm going to say we're going to work backwards. All right, what does that mean? We know the charge of chlorine.
Looking for the other officer McCauley.
Chlorine's got a -1 charge. There's two of them. So there's two -1s. All right, now balancing that is going to be a copper with the charge of, I'm going to say plus X for right now, right? I'm going to use the X just like I would in any other situation in a math class. I don't know what it is yet. But the magnitude of the negative charge is always equal to the positive charge, right? So that would be the same as saying the absolute value. So X is going to equal -1 plus -1, so the absolute value of -2. So what does X equal? Just 2. So we write that as a Roman numeral. So this is copper to chloride. Each chlorine is gaining an electron, and it gains those electrons from copper giving up 2 electrons and becoming +2. All right, so we'll look at another example. All right, we have Fe2 S3. Fe, it's iron, it's a transition metal, so it's an ionic compound, but we're going to need that Roman numeral. So we know it's going to be iron, some type, sulfide. Sulfur, it's in group 16 on the periodic table, it's got a -2 charge. There's 3 of them. So that means each sulfur has gained 2 electrons, there's 3 of them, so they have gained as a total, they've gained 6 electrons. Those 6 electrons come from our iron. But I want you to think, there's 2 irons with a plus X charge. We don't know what that charge is yet. So what we're going to do, we're going to say 2X equals the absolute value of -2 plus -2 plus -2, the absolute value of -6. So 2X equals 6, and this is a very easy system, and this is a very easy equation to solve now. X equals 3. The charge of the iron is +3, so we write it as a Roman numeral. All right, and we're going to do one more example so that we get really good at this. MnO2. It's manganese. It's another transition metal, so we're going to leave the parentheses. It's oxide. Oxygen, group 16 element. It's got a charge of -2. All right, so the total is going to be -4. We're going to take the absolute value. The manganese, we don't know the charge yet, so I'm going to make it the X. X equals the absolute value of -4. X equals 4, so this is manganese, 4 oxide. All right, we always figure out what the total negative charge is, and then we make it a positive for the metal side, and we divide if needed. So in the iron situation, we divide it by the subscript. So we divide it both sides by 2. All right, but that's what we're doing to figure out the Roman numeral in any ionic compound with a transition metal.